In these problems, we're talking about something called irrational numbers. And this doesn't mean numbers that aren't very logical or don't think straight. It means they can't be expressed as ratios, that is, as a fraction. So there's some numbers that there's no fraction for. These are numbers like pi or the square root of 2 or the square root of 3. And there's something you might notice about these numbers if you plug them in your calculator. If I take a fraction like, let's say 5/7, I can do that on the calculator as 5 divided by 7. And I get this big long thing, and it goes off the end. So this is a decimal that never ends, but you'll notice it repeats. I have 0.71428571428571428. So it's a repeating decimal. So this one is a rational number. It can be expressed as a fraction. A number like pi, again, it runs off the end of my calculator here, but it never repeats. 3.145926535. There is no pattern in there. There's no repetition. And some people spend lots of time trying to memorize pi to 100 digits or 1,000 digits or even further because it's such a feat of the memory to be able to commit to memory something that has no pattern to it. So an irrational number, it can't be written as a fraction, and it has decimals that never end and never repeat. Now, when I say a fraction, I mean a fraction of two whole numbers. Okay, so let's look at some of these problems here. This first one says, which of the following is an irrational number? And we see some square roots in here. Well, this one is just a plain old decimal that ends. So I know that's not it, because irrational numbers, they have decimals that never end and never repeat. This one, well, the square root of 4, I know that's 2, so this just comes out to -2. That's not an irrational number. This one, the square root of 36 is 6, so this really would be 1/6, -1/6. That's a fraction, so that can't be it. So it must be the square root of 15 unless I've made some mistake. If you're not sure and you want to verify it, just plug it into your calculator and you'll see this is a never ending and a never repeating decimal. Let's look at one more. It says, which of the following is an irrational number? And here we have a dot, dot, dot. So it looks like this is a never-ending decimal. So that's a good clue. Oh, except it repeats. The 979797 goes on repeating. So that's not it. Here we have pi over 2. That looks like a fraction, but it's not a fraction of two whole numbers. This pi is an irrational number. And pi divided by 2 is going to be the same thing. So whenever you see pi, that's a likely candidate. The rest of these, square root of 16 is just 4, 2/11 is a fraction, so those are going to be rational numbers. So when you're looking for irrational numbers, keep your eyes out for pi, square root of 2, square root of 3, and things like square root of 15, where it's something multiplied by the square root of 2 or square root of 3. And if you're not sure, just plug them into your calculator and see if you get a never-ending, non-repeating decimal. So that's a little bit of work with irrational numbers.